Okay, recording has started. Hi everyone, welcome to Cloud Robotics Working Group meeting, first one of 2026. We're looking at logging and observability again. And we have a note, which is a short list of from our previous meeting. So let me share that link, and then I will share my screen. Hello, talk shortlist. There we go. Yeah. So we went through. We had a look at a few options of things that might be relevant to logging and observability. Since then, I went to the original site that they came from, and I got links from that site, and I basically just copied the more info link and the video link from the site, and I also copied the transcript from Vimeo into a new Google Doc sheet per video. So we don't need to watch the video. We can look at more info for a bit more info, and if that's not enough, we can look at the video transcript. So my thinking is that we can together look at the most relevant videos, see if there's any themes we can pull out, any interesting observations, and then just write a short blog post for Cloud Robotics Hub. Hopefully we can get enough from this meeting that I can go ahead and write the blog post after the fact.
Thank you.
Yeah, thanks for doing this. I'm really curious about that the first one, open source observability at scale. The first question is, I mean, when they say open source, that sounds like they are putting together like a stack, right, of different open source tools. So I'd be very curious to see which those are.
Yeah, so actually the Canonical one was very relevant. I watched 2 videos as well. There was another one that I thought could be very relevant. I think it was this ClearPath Robotics one. And while you can stream things from a robot, it was very much based on a robot. So like a laptop talking to a robot. I think for the Cloud Robotics group, it probably isn't that interesting. You can get robot data off for logging and observability, but I think we're more interested in Canonical's approach, which was fleet level. It looked like exactly the kind of stuff that we have been looking at with logging and observability. So I do think the Canonical one is worth digging into. Otherwise, we had Roboto AI's ROSBag analysis, and I've just realized that I'm recording the screen without the video in. Let me see if I can pull this out separately. That's better. Okay. Sorry, can you please share the docs link? I'll reshare it. It's just above, but I think maybe it wasn't available because you joined just afterwards. So there it is again. So how to do this, I'm not quite sure of. I think we can just open up more info together, scan through it, see if there's anything interesting. We'll do it in order from most relevant to least relevant. And I think we can start with the Canonical one. We can look at Roboto AI, although we should know most of it from the talk we've had. And the ClearPath Robotics one, I think it might not be that helpful, but let's not just rely on that. Let's look together. So let's begin with this one. And I'm going to change my screen share to be the whole window so that you can see that as well. There we go. Okay, so bring the call. Sorry about this. It's because I don't have the window highlighted. It started doing picture-in-picture, so the meeting recording can't see what I'm presenting anymore. Bring the call back here. On my screen anyway. There we go. The video recording getting in the way there. Okay, so I'll share the link again in the chat, so you can read it directly on your screen if you want. Otherwise, let's skim through this and see if there's anything we want to discuss, pull out, make a note of.
Could you open that image? I don't know whether you can full screen that somehow. Yeah, thank you. Okay. So there's the device. That symbol, I think, is FluentBit, right? That little bird with the red red neck at the bottom. I think that if I remember, that's FluentBit. Grafana agent, Foxglove bridge, ROS2 exporter agent. There's an MCAP image in it, so it seems that's like some sort of MCAP tool. Cross registration agent. And then Foxglove, Grafana. I think Loki, right? That thing to I'm going through the first icon is Grafana. I don't know what that flame is. Maybe Prometheus.
Did you say Prometheus?
Prometheus, yeah. Then I think that L is Loki because it uses the same colors as Grafana and it's part of that stack. Not sure what the bell is. The Foxglove Studio, we know. Robotics data file server, that's again MCAP, I guess. Okay, so that's a fairly well-known stack. What I'm not seeing much, well, I guess Prometheus is let me look up the Prometheus icon. Yeah, that's Prometheus. So that's pretty standard. That's a pretty standard stack. Okay, thank you. So far, nothing too surprising.
So the workflow is devices, a fleet of devices that push data, and I think they're trying to make it as easy as possible to install, hence using a snap.
Yeah. That's what you would expect from Ubuntu, right?
Yeah.
For Canonical, they're putting snaps everywhere. But they don't, somehow, I was scrolling the text while you were looking at the figure, but somehow the text is not aligned with what they show in the figure. So they don't mention any of the technology by name, neither on the server side nor on the device side. They just say there's telemetry collector, data collectors, log collectors, VPN client, and device management client. It's a bit, maybe the transcript, you've seen the video, right, Mike?
I have,
maybe the transcript says more, or
it does. I remember it being more specific, and it had a demo as well. I seem to remember, or at least it showed what the dashboard looked like, if not a live demo. But
yeah, because this this page doesn't tell me much. I have to say.
It was a while back, but let's see. We'll finish reading through, and then let's open the video up and see if we can find the screen, because I think that'd be quite interesting. We can look at the transcript as well.
I just noticed cost for robotics components on the left. Is that maybe the one where they talk about?
Maybe, yeah.
Okay, here at least they talk about Foxglove and the registration, some of the things that we saw there.
Yeah.
And then
indeed you were right. After cost slide components, there's Loki, Prometheus, Alert Manager, Grafana, Traffic, which is
so maybe it wasn't FluentBit, but Traffic. Yeah, I recognized the logo, but I couldn't tell from where.
I'm too far behind to recognize now all the technologies from the Kubernetes space and their logos.
Traffic's a reverse proxy.
Yeah.
So I'm imagining it's a central point for data to arrive, and then it distributes it to the right service from there. But that's
there's all these. I think wasn't it Tomoya who gave a talk here on FluentBit, and I think Traffic is like there's all of these log processing tools like log ingest and forwarding and routing and all of that, and I think Traffic is one of them. I think it is comparable to FluentBit and FluentD, but yeah, I'm not totally sure.
I don't remember. I seem to recall it was connected also to ingresses in Kubernetes, but I haven't used it for so long. I don't remember all these things now.
It said reverse proxy on top. Okay, so that's different.
Ingress integrator and reverse proxy.
Okay. What I don't quite understand is why do they have so many different ingest things, right? Like Grafana agent, Foxglove bridge, ROS2 exporter. Can't quite tell how they are going to work together.
Maybe a future meeting should be diving into this a bit, a tryout.
Yeah, maybe.
Figure out how it all works together. I think it looks interesting from the video. Shall we pull the video up and see if we can find some interesting screens?
Prometheus to record metrics in time series database, Loki to aggregate logs from your infrastructure, from your applications, and Alert Manager send you an email or notification whenever you get an alert. And the core stack, as it is well adapted to monitor other servers.
So that's Grafana.
As links to the different applications pre-configured for this device. Here we select the Linux dashboard, the Grafana Linux dashboard, and we can see all the CPU, memory, storage, network information from this specific device. Additionally, we have another dashboard called systemd and snap logs. This dashboard shows you all the snap logs, snap application logs, systemd services logs for this specific device. You can easily filter through it and everything. These dashboards, they are example dashboards that we provide. You can obviously customize your own dashboards, and you can benefit from all the dashboards that are provided by the Grafana community. Additionally, we have Foxglove with the teleop layout. So here you jump directly to the teleoperation of your robot. You can start teleoperating your robots directly. Since the robots are registered on the server, we know how to establish the connection to them directly, so you can start teleoperating it. Additionally, we can record ROS2 bags continuously and sync them on the server. So here, if we select the bag files application, we get to see all the ROS2 bags that we recorded for this specific device. If you're interested in a specific bag, you can copy the link, jump to Foxglove Studio you've deployed, and here paste the link to access all the data. Here you can inspect the data from the ROS2 bag.
So I think there's some overlap with transitive capabilities, isn't there, Christian?
Yeah, I noticed that too. It seems like they're actually trying to. Yeah, not exactly sure. They call it an observability stack, but then they also show a link to pull up Teleup in Foxglove. Yeah, I'm trying to wrap my head around it, what it is and what they're trying to do. Maybe I'll reach out and chat with them, see whether I can shed some light on it. I might report back from that.
Yeah, sounds good. Whether we can pull something interesting out of this to share on a blog post is another question. I guess their architecture might be something to look at. So,
their what?
Their architecture. I don't know if there's much we can say, because you have a cloud server and a device agent, and that's pretty normal.
pretty cloud and robotics, I would say, in the architecture.
Yeah, that's the thing that I was missing there was how do you do the communication, right? Because the big point of transitive is, of course, that we built this on top of MQTT and built like a data sync protocol that allows us to do a lot of things. But if this is, it's hard to call something an architecture if it's really just sort of a combination of existing things, right? Like, okay, so we installed the Grafana agent and the Foxglove bridge on the robot, and we installed Prometheus and Grafana in the cloud. I wouldn't call that an architecture. Like sure, that's a stack, but it's not. It's hard to call that a thing. You know what I mean? Like it's more of a recipe, and that might be fine, right? And in fact, some of our listeners might be wanting to hear exactly that. Like, what is a good best practice for instrumenting your robot? And maybe we don't actually need tools and architectures and frameworks. And that's where I'm unsure, because at the same time they show like this portal-like page, right, where they show all of the robots, and that's clearly something that they have built. Yeah, not sure. I'll try to find the time to look deeper at that.
Just writing notes on that. Yeah. So back in, I can see that I don't seem to have copied the whole transcript like I thought. I basically just hit this button
and looks like a subset. Yeah.
Copied all of it, but maybe it only copies what's on the screen, even though I thought I'd highlighted everything.
Yeah.
Websites are funny like that, because nowadays often when you scroll to the bottom, they truncate the top so that the list doesn't get too long. So you may be thinking that you're actually selecting everything, but as you're going down, it may sort of be unselecting or eliminating from the top.
I think
so. It can be tricky. If the transcript doesn't provide like a copy function, then you may need to, that might be a better approach. Yeah.
As long as it doesn't dynamically load in data when you scroll.
That's what I mean. And then worse, sometimes they drop at the top to make the list perform better. It's really ironic that browsers often cannot handle very, very, very long lists, when good old Linux tools on a Pentium 2 were able to scroll through like thousands of lines just fine.
Yeah. There's probably a selector. You can just combine everything from chakra stack P and pull the text out. That's a shame that I didn't check the transcripts. I just copied and pasted and thought, that looks good, and moved on. But at least we've still got the transcript here, so nothing lost.
But indeed, Christian, they call it canonical observability stack for robotics. So they don't claim it's an architecture. It's just a packaging of components that you could use to implement observability, and opinionated with Juju to run.
What was Juju again? They use it in the same context as Kubernetes. Is it some
sort of... Exactly. It relies on Juju, an open source orchestration engine to easily deploy application at any scales, and micro Kubernetes. So I remember Juju for a while when I was trying to manage my own Kubernetes servers was one of the things I had tried to use with very limited success. Probably a skill issue in my case.
Okay. So similar to what Tomoya was telling us about, Kubernetes at the edge, Kubernetes for like deployment and management of services. I think Tomoya went a little deeper than, well, I guess we're only scratching the surface here. We don't know how deep they went, but I remember him doing some pretty advanced stuff there with dynamically starting services depending on like on demand, if I remember correctly.
Yeah.
That was pretty cool.
Yeah. He was basically managing the robots as part of the cluster. So
that's right, and multiple nodes on the robots, if I remember correctly, right?
Exactly.
They would fire up only when needed.
So he was using this very elegant mechanism of tagging that you have in Kubernetes to decide what things can be started where, so that you can actually control all your fleet of robots and start and stop things on them, depending on tags, which is extremely powerful, of course. It's really a cluster management brought to a robotic fleet.
So that is an observation on its own. Their Canonical are also using Kubernetes to deploy. Is it just server side they're deploying with it?
Yes, as far as I understand, yes. So they say the server side relies on Juju to deploy application Scales and micro Kubernetes, and then on devices, Snap packages.
Yeah. So CS uses Kubernetes for cloud side deployment and scaling. Snapped on device.
And then they talk about P2P VPN, which I'm not sure they give more detail with. One of the things I'm seeing everybody using lately is Tailscale for having this nice sort of safe peer-to-peer VPNs with not traversal, basically. So you have no public IPs anywhere, and that's pretty sweet for as far as Cloud Robotics goes.
Yeah, funny tidbit is that Tailscale and WebRTC are extremely similar under the hood. They both use eyes. They both use like a signaling server, the server that helps you put the connection. In WebRTC, it's called either the stun or the turn, depending on whether it also proxies. In Tailscale, it's called the DERP, DERP. For some reason, it has to be a 4-letter acronym. I don't know why. And but other than that, I think it works very, very similar, right? Like it's the real magic is ice, right? Like that NAT circumvent, like hole punching.
Hole punching in the NAT, yeah.
And then it's different applications of it. That's one way to summarize it in a sentence, right? Tailscale uses it for network level connectivity, and WebRTC uses it for browser.
But I was really wondering about it. I mean, I remember I did ask Gemini a while ago if I had the Tailscale network, how much harder would it be to put WebRTC on top of it? And it says, it's very similar, exactly the thing you were saying. But then it didn't give me a very good recipe on how to do it, and I didn't try it.
Yeah, you don't need Tailscale to put WebRTC on top. In fact, they sort of interfere with each other sometimes because they have sort of their own routing ideas, right? But you could try to rebuild. In fact, I just talked to somebody who was thinking of reinventing WebRTC on top of Tailscale, and then of course you're just at the doorstep of all of that video stuff, right? You still need to worry about video encoding, jitter buffer, congestion control, packet loss, and stuff like that. None of that is taken care of, but the communication infrastructure is there. I guess one thing that I look at, one question that I have in mind as I look at these things is, what are the learnings? Like, what are the results from these talks? And like, what is it that I should remember? Obviously, I remember that Canonical is doing something. Okay, fine, but that's not very actionable. I mean, that's something. Okay, fine, maybe I'll try that out, but it doesn't tell me much about how I should, if I was a practitioner, right, and I have a fleet of robots, I want to do logging and observability, should I follow this approach? Should I follow Robotus approach? Should I follow the third one that had a 5 in our listing, ClearPath, right? Like, which of these? It's maybe I'm too academic, right? But in our papers that we wrote, we always had to have some sort of result, some empirical evaluation, some theorem, something that is provable and well, yeah, I don't know. I'm circumscribing what a result is, but I guess you get it, right? I'm missing that here, but we haven't looked at that yet. Maybe they do have it somewhere.
So if I understand right, you're saying that they're showing that the software exists, saying what it does, but they're not describing the path they got to it and why they made the decisions they did.
And some sort of evaluation, like, was it a good idea, right? I mean, there's a category of paper when you review papers where after reading it, you just say like, okay, they described what they did. Great. Now I know what they did, but I don't know whether that was a good idea, how it panned out, whether, so some sort of, evaluation and comparison to alternative approaches almost would be interesting.
Well, it might be interesting to ask them to come and talk to us.
They might. In fact, he might be happy to.
And those are the sort of questions we can ask, not just what can it do, but why.
Mm-hmm. The why is often a very hard question, because in Canonical's case, maybe it will work. With robotics companies, the problem is often that they simply don't have the time to try several things. So the first thing that they get to work is what they're going to run with, and then the result is it works. Let's move on.
Mm-hmm.
And not like this is the best that we could do. And of course, so then perhaps the more interesting would be to hear, like, why did you decide to try this one versus the alternatives? Like, what were the criteria that you were looking at as you were comparing these stacks before implementing? Not a part of the information that you very easily get, because once they have committed to something, they typically want to talk about what they've built. And not why they build it. But maybe in Canonical's case, it's a little different, because I can't quite read them, right? I mean, it's not their business model to make robotics stacks. So, and they don't operate robots themselves. So they're a little different. I almost think of them as more researchy, which also reflects in them, presenting at ROSCon. Yeah, we'll see. But I think it's a good idea to invite them.
I pasted the link there. It seems that I was clicking through their documentation, and the link I sent you there's a new page for observability, and then they have an explanation what is observability, model-driven observability. They also have a design goals section, architecture and design. So if you click on the link that you're already there. I guess I'm clicking on explanation. I clicked on explanation on the left there. Yeah, and then there's architecture, there's design goals, there's a bit more explanation, I guess. I haven't clicked on those below, but it seems but I mean, they're really high level logging architecture. It doesn't. Okay, there's a bit more on the logging architecture, but this is really just Loki and the way logging works.
So this is an observability stack, actually not specifically for robotics, it seems. And then the talk at ROSCon was, and this is what it looks like when you extend it for robotics.
No.
Am I understanding that right?
Yeah. Early on, they say they add extra stuff so that it can work with ROS.
I see. Well, the
robots need
question
additional
then
features.
is, whenever this is of course along the lines of what most robotics companies do at first when they need a web stack, cloud stack. They just go and take good old server monitoring tools and apply them to robots, because hey, that robot looks like a server, so let's call it a server. And then after a while, they realize that robots are actually very, very different. And one of the big issues, of course, is network, right? Servers don't tend to go offline, at least unless you work at Cloudflare. But the robots go offline all the time, right? So I don't know whether they accounted for that. That's often where it becomes problematic, right? Like, typically a question that I get from transitive customers is, well, what do you do when the robot is offline for a while? What happens with the stuff that you want to upload to the cloud? Like, do you cache it when you and then when it comes? Funnily, one of the questions that I get a lot is, when the robot comes back online, how do you make sure that the newest data is uploaded first? Because typically, if you just rely on TCP, for instance, right, it's buffered in the order in which it was sent, which is not the order in which you want to receive it. So there's some interesting questions there that I would ask them. I like the idea more and more to invite them to come here. If they do come, maybe we can ask them all of these questions.
Grill them.
Grill them. I didn't want to use that word. It was on the tip of my tongue.
Yeah, but I have the same impression. And indeed, if you click on the links on the left side there's a high level design goal. Then they show how they do logging, how they do telemetry, how they do correlation. So it's a bit like, indeed, something taken from the server management simply applied to robots, and as a lightweight observability stack.
Which would imply they're treating them as servers still, like Christian said.
Well, is this page even for robots, or is it just an observability stack that they imagine for?
I think it's
general,
I think it's this is the generic canonical observability stack, and the robotics one is the lightweight one.
Yeah, he did mention cost light somewhere.
Yeah, exactly. They call it cost for robotics, and then I guess the link I sent you is the generic observability.
That makes sense. All right. So I guess, oh man, it's 24 minutes to the end of the meeting. Maybe we should have a look at the others as well. Anything that we can pull out of this before we click another link?
No.
Yeah, I guess they're attempting to use industry standard stuff rather than building their own dashboards like we've seen from some of the others. They're using Kubernetes, which is interesting, but not on the device. And yeah, snaps on device, which makes sense for Ubuntu. I guess they've probably realized that a lot of robots are running Ubuntu.
That's because of ROS, right?
Exactly. Yeah. Let's capitalize on that. Yeah. All right. Let's have a look at what else we have then. So that was our top. We can have a look at Roboto AI. And I think, yeah, we're looking at the similarity stuff, which was really fascinating. You can find similar events from the search. So this is probably more in depth into that.
Yeah, this one we know this is really good stuff. Eve, by the way, is here in Zurich. They organize events every month or every other month, so I see him quite regularly.
Nice. Yeah, same here with Benji. He's not actually in the Bay Area, but he keeps coming down, and I always ask him, like, how much time do you spend, like, anyways, he sort of lives between SF and Seattle, so coming down here all the time. Are you talking about Europe, and are you going to FOSDEM?
I'm not. Mike is, no?
I am going, yeah.
Nice. It sounds like it's going to be a lot of fun.
You're headed as well, are you, Christian?
No, I'm not. No.
Yeah.
Could, but it's too far.
I was trying to figure out what sort of open source I could talk about, but I realized that I don't contribute enough to open source, and I'm slightly ashamed.
It's mostly for contributors, because you do talk about a lot. Yesterday I was watching a video on the joint controllers. I mean, you talk about and you know how to use open source, and I think it's a valuable contribution. There's so much to learn and find out. It can be daunting. So I don't know how FOSDEM is structured. I guess it is mostly a contributor conference.
I heard before that it was mostly people that had an open source repo that could talk about it. But maybe I should have asked you this before the deadline, Christian.
I don't know. You've looked at it more closely than I have. I'm just pointing out that, open source is not just the repo. It's also, spreading the word and making it usable and
teaching people how to use open source, which is what you do.
just grow because you throw some seeds. You also need to nurture it. You know what I mean? And that's just as important.
Yeah, maybe I'll see if I can get a late entry.
It'd be great.
So this is interesting that, just like you were saying, we didn't see in Canonical's video. This is about what it did and what it couldn't do. That's quite interesting. You can learn something from it. I don't know how much we can pull out of this for a blog post. I figure we can definitely say it's very cool. We've got a video of this already. Check out this meeting video.
Yeah, the other thing that I'll say about Roboto is it's a product. You can use it, right? The other talks are more, again, trying to think from the perspective of a robotics operator who wants to do logging and observability. I think one question that they have is make versus buy, right? And Roboto may be a buy option, right? Like I'm going to use an existing stack and it's great and it has all of these features. And it's great that they have these talks because then you can see like what you actually want to get out of it. Like these are the questions that you should ask yourself. And then Canonical is more on the build side, right? Like make side, where they show you how you can quote unquote make it yourself based on open source, and then maybe you can extend it. So because of that, I would look at them very differently, right? Like I would look at the Roboto one in terms of, oh great, these are the features that I should want, right? And now, but the how in some ways doesn't matter because it's closed source anyways, right? I can't look under I can't change it. And then I would take that and compare that to the other ones and see like, well, can I actually pull that off with those, or how do I make that trade-off?
That's a great point to discuss.
Yeah, it's actually Benji and I talk about this sometimes. Like we ran into each other at Robo Business, and we talked about it, that a lot of people underestimate how hard it is to build these things, and partially that is because they don't even know what the questions are that they should ask ahead of time until they find themselves in the middle of it and realize, oh, it doesn't just magically work. And part of the problem is what I was alluding to earlier with Canonical, right? That the tools are often described as, yeah, you just plug it in, you install it, and it works. If it is a server in a data center that has a wonderful bandwidth, there's you guys probably know the 9 fallacies of networking, or was it 7? I forget what it is, but one of them is the network has no bandwidth limit. It is always available. There are no, packets never get lost. I don't know. I forget. And of course, none of them are true, right? But for the most part, they are. And then people often design it like that. And then data centers obviously behave a lot different from robots. So that's where a lot of the optimism turns into, or that's the source of false optimism in many cases.
Should we look at the next ones then? But the only other one that we had with high relevance was ClearPath. No, Mike, that's and you were saying that one you don't feel it's, or did I misunderstand?
No, you're right. I think it's very focused on a single robot. So the idea I remember from the talk is that a technical person can SSH to a robot. They can look at ROS data with command line tools. They can figure out what's going on. A marketing person that wants to record a demo has none of those skills. How can you make it available to someone like that? And that's kind of what this is. It makes the robot produce a web server. You can access that web server from a laptop, from a phone, and the main screen says everything okay. And it's going from right to left, new samples coming in. And when you start to see errors come in, it gives you human readable errors. So it is observability. It is collecting logs. It's not collecting logs at a cloud or a fleet level. It's very much only when you connect to it, you can see what's going on.
Mhm.
So
Is it
I think
actually collecting logs? Because this is something that I've seen in many forms, and it was actually the first capability that we wrote for Transitive, which is just a web visualization of ROS diagnostics, right? Like, because what you're seeing here is like literally one-to-one mapping into ROS diagnostics, and that's probably what's behind it. That's why they're also calling it ROS2 diagnostics, which is, you know, just like the error, like there's different levels, right? You have sensors basically, and every sensor can be an error, warning, stale, or I forget what the other one is, or good, of course. Okay, I forgot about that. And then every sensor can have values, right? Where, like, such as, so for instance, you can have an aggregate where you say the battery is healthy, but then there's also a value where you see, let's say, the voltage of the battery or something like that. And there's, you know, in RQT, there is a visualization for this health that is modeled again like this. And then in Transitive, we have the same thing. So that is, to me, that is like a very, very basic type of observability. It's a good one, and for the following reason, it's good in the sense that it's very extensible, right? Because everybody, the way that we used it at Savioke was that we would say that if there was an issue in the field that we caught, we don't just go and fix it in the code. We don't just go and add a test case. We don't just go and add a release test case. We also add a ROS diagnostic sensor that will tell us whether it gives us some sort of warning about this before it, you know, becomes visible to the customer. So it's like an additional feature that you can use in robotics. And for that reason, it's very useful because it makes observability a group effort, right, or a team effort, where everybody on the team is responsible for adding, just like they're responsible for adding unit tests, they're also responsible for adding sensors, as we call them. I don't know whether that's the correct term, or diagnostic measurements that state whether their piece of the complex robotic stack is functional or not. But it's very different from logging. It's very different from metrics. You can do metrics here, but not quite at the frequency, not quite at the type of temporal resolution that you usually do these things.
Yeah.
Then I'm not sure I understood, Christian. Then you for issues that you found on the field, you would create a test that would write a diagnostic message if it was.
No, several things. So we would create a test. So let's say we have a bug in the. I'll give you one example. I think that's fun to share. We had a mismatch between the frequencies, I think, of the local planner and the motor controller, and what that resulted in was the robot being drunk. It would like go in curves, and that was because there was like one was overcompensating for the other. It was too slow, right? Imagine like you're trying to navigate actually an airplane. If you've ever flown an airplane for the first time, you tend to overcompensate. You go like, you think you're going too low, so you're pulling up, and before you know it, but there's lag in the control, right? So you are going up, but you're going up too far. So then you're pressing down again. And so anyways, we had an issue like that. And then, you know, we found the issue in the code, so we fixed it. That's, of course, the most important thing. Then we added a unit test so that next time we run our test cases, we would detect whether we had a regression in that. That's also still normal software engineering practices. But then on top of that, we also added a diagnostic sensor, which is something that runs at runtime. So now we could see the entire fleet, like once that sensor was deployed, like the new version would touch that sensor, was deployed to the entire fleet, we would have you know how it says here, their screenshot is not very good because it just says clear path diagnostics. Normally it's broken down further, like much further. I can show you some screenshots. Where you would have like motor controller / such and such / such and such. And we would add that, and then we would be able to see for the entire fleet whether or not it was healthy.
Mm-hmm. And basically, your new diagnostic sensor in this example that you were saying would be something that would measure the frequencies of the two
details,
something like that.
something along those lines. And that's then on the developer to find a measure, a runtime measure, similar to a unit test, right? In a unit test, you run some code and then you have an assert or some sort of test condition. This is basically the same. There's some sort of condition that you want to be notified about. The art, of course, is to make these sensors in a way where they don't flicker a lot, because that's not very helpful. But you could do something like another example that we had a laser shroud, right? So we had a 2D laser, and there was some plastic casing around it that would, that was part of the shell of the robot. When you can't just make the robot flat down, because the laser needs to have needs to look out. So the kind of sort of a bay, so to speak. Anyways, that was a piece of plastic, and depending on how you assembled the robot, it could be under the front panel or above the front panel, right? It needs to sort of fit in, and it was very easy to get that wrong when you assemble the robot. But the problem was when it was below, then it wobble a little bit, and depending on when the robot was driving and how it was leaning and whether it was stuttering, it would get into the laser rays, and then the robot would say,
"There's an obstacle right there, 5 centimeters from me." Okay,
it's scary. I need to stop. And so you can imagine how that looked for the robot, right? It would stutter, it would stop, sometimes it wouldn't move at all. And it was very expensive for us to, bring people there just to take the stupid casing off and put it on. I've done it several times when I was down in LA, when I had to do it, because all of us, when we were traveling, we would always let field ops know, I'm close to such and such robot. If there's a problem, just let me know. But and it's so silly and it's so easy to be detectable. And so now we added then a detector that would say, I have been seeing an obstacle within 8 centimeters or something like that, which should never happen. And then in the moment that you put the robot together, you would turn it on, and you were not supposed to leave until the health checks are all green, right? Clearly. Yeah. So that's one way that we use it.
The incident you were talking about before reminded me of something. I quickly vibe coded now a visual servo logic for a humanoid to grasp things. And I realized I got this wobbly motion, and the problem was exactly that my control loop was too slow. So and it was exactly that thing. And after I realized, okay, if I manage to get rid of some segmentation parts and get rid of some parts that I don't need to run at every loop, at every cycle, then I got the good behavior with the arm going the right way. Yeah.
There's I'm sure control theory people would cringe at what we're saying here, because of course they would say, you need some model predictive controller, or a PID controller will take care of that. You just need to know not to over control, but that's robotics for you. You can't be an expert in.
I mean, the implementation uses a PID. The problem was that I added so many things in there that the cycle of the PID started to become the period of the PID started to become very large. So it was initially worked very well, and as I added features to make it more robust, the period grew. So.
I love that anecdote. It's so true. That's how things work. You think you're making things better because you're focused on one thing, but then there's all of these ramifications that are very hard to keep track of.
That is a good one. I might steal that. I went through the video and found an example warning. So they did an e-stop to show that there was a warning, and you can see it streaming across the timeline, and it's there in the diagnostics. But I think you're right. I had a quick search through the code. I don't think they're capturing logs. I think it probably is just diagnostics messages. I also think it might be specific to ClearPath robots, which makes sense.
No. ClearPath robots are very much. I mean, they're a ROS contributor, right? So they stick to ROS as much as possible. Here's an example of what we have. I don't know. Can you see this?
Yeah.
This is just an example of this. This is from a robot, probably even one of the demo robots that we had. you know, like you typically break it down a lot more, and it uses the same sort of topic type of breakdown as ROS does or MQTT. And then you can, when you unfold it, this is just our way of visualizing it, right? But it's very close to what's actually on the wire and how it's represented in ROS messages. And then typically, oh, sorry, I didn't mean to stop sharing. Yeah, and I guess you can imagine how you roll that up to a fleet, right? Like, so, you know, typically a ROS company would have like a dashboard, often like even a 2V on the wall, right, where they show the entire fleet, and of course there you want to see high level. Is the fleet healthy? Which ones need help, and so forth. So this lends itself to rolling up.
That does make sense. All right, we've got 4 minutes left. I think our next highest rated video would be this one. So I think we don't really have enough time to look into it properly. So I suggest that I'll write a blog post based on what we've discussed so far. I might have a quick look at the more info and see if it's relevant, but I'm going to assume it's not. And then hopefully I can publish something before our next meeting, and also invite the Canonical speaker, see if they want to dive a bit deeper into the Canonical observability stack.
Very good. That sounds great.
Thank you.
Sounds good. All right. Thanks for joining, everyone. We'll end there, and I'll see you next time.
See you.
Thanks,
Bye-bye.
guys. See ya.
Happy New Year.